Hello class, I'm working out of your Algebra 2 book 1.8 absolute value equations. To get started, absolute value notation are two vertical lines and the number in the middle is the distance from 0 on the number line. So if you have something like 1, 2, 3, -1, -2, -3, then we would say the absolute value of 3 and the absolute value of -3 are both +3. Absolute values always answered in the positive because it's just the distance of units of 3 to 0 on the number line. Also, the distance of units from -3 to 0 on the number line. You have a value A and a value B. The distance between the two equals the absolute value of B minus A. And the midpoint between the two equals A plus B divided by 2 to find the midpoint between 2 points on a number line that are graphed. Alright, if you have something like the absolute value of x equals 2 and you're asked to graph, then x is 2 units from 0 on a number line. That means that x can be 2, but also x can be -2 because both of these are 2 units from 0 on the number line. So 2 possible answers in the integers. Alright, if you asked to solve something like absolute value of x plus 5 equals 9, then if we drop the absolute value symbol, we have x plus 5 equals 9, the original given equation, or x plus 5 equals -9. Alright, so we solve algebraically for both, and that gives us x equals 4 here, or x equals -14. for our solutions. So set up two equations when you drop the absolute value symbol. Alright, if you're asked to solve something like 2 times the absolute value of 3x minus 12, absolute value minus 8, all equals 24, then get it to a point where we can find our two equations. Let's drop the extra information. So what that looks like is we're going to get rid of this minus 8 by adding 8 to both sides. Okay, so 2 times the absolute value of 3x minus 12 equals, and then that's 24 plus 8 is 32. Hey, help yourself out and just divide by 2 instead of doing distributive property here. So be able to see that. You're going to get absolute value of 3x minus 12 on this side equals 16. So from here, you can find two equations if you drop the absolute value symbol. So you're going to find the original 3x minus 12 equals 16, or 3x minus 12 equals -16. Okay, so 3x minus 12 equals 16. We're going to solve that by saying plus 12 plus 12, and we're going to get 3x equals 28. X equals 28 thirds. This is a possible solution. Our OR equation was 3x minus 12 equals negative 16. Okay, so we're going to add 12 to both sides. That leaves 3x equals negative 4, which x now equals negative 4 thirds. That's a possible solution. We're going to check. We're going to go back to our original equation and pop in the x substituted in for each equation. Check it out. Okay. So if we do that, we are going to go back to the 2 absolute value 3x minus 12 minus 8 all equals 16. Or excuse me, 24. So we got 2 times 3 times the first x, 28 divided by 3, times, or minus 12, absolute value, minus 8, all equals 24. We just substituted 28 thirds into the original equation given. We're going to solve for this. 3 over 3 is a fractional form of 1. 1 times 28 is 28. 28 minus 12 in absolute value leaves 2 times 16. Minus 8 equals 24. We're going to add 8 to both sides. See if I can work that out. Alright, so now we have 32 from 2 times 16 here, this goes away, is equal to 24 plus 8, 32 here, check. So x equals 28 thirds is a viable solution. Alright, so we're going to pop in 2 absolute value of 3 times negative 4 thirds. All minus 12 absolute value minus 8 equals 24. Alright, 3 over 3 is fractional form of 1. So now we have negative 4 minus 12 in the absolute value. So that leaves us with 2 times the absolute value of adding more opposite. Negative 4 plus a negative 12 is more negative, so it's going to be a negative 16 in the absolute value. All minus 8 equals 24. Absolute value is the distance from 0 on the number line, so that negative 16 is now positive. Okay, we're going to add 8 to both sides. We're going to consider our positive 16 when we drop the absolute value symbol. That's 2 times 16 is 32. This goes away. 24 plus 8 is 32. Check. That means x equals negative 4 thirds is a possible solution because the check is equivalent. Alright, if you're asked to solve something like 2x plus 5 in the absolute value and it equals a negative 4. Absolute value is not equivalent to a negative value. So this is not true, no solution. Okay, another example. We've got the absolute value of 2x plus 9. Make your absolute values big so it doesn't look like a 12. Just to help yourself out. And then 3 minus 8x is on the other side. So if we drop the absolute value symbol, we're going to get two equations. We're going to have 2x plus 9 equals 3 minus 8x, the original equation given, or 2x plus 9 is equal to, watch what happens here, we're going to make the 3 negative but the 8 positive. It's like multiplying by a negative 1. Then we're going to present the variable x term in front. So positive 8x minus 3. It's the opposite of the original given equation across the equal sign to consider the other equation for absolute value. Okay. So we can solve for both of these. You want to keep your x terms positive, so when you evaluate your algebra, be sure that you're actually finding what carries more absolute value. So negative 2x and negative 2x would cause x to still be negative. But what if we added 8x to both sides? There, that works. That keeps our x positive and we get a 10x there. These go away. So if we did that, that's going to be equal to minus 9 on both sides. This goes away. And we get this. So now x is equal to negative 6/10, which means it's equal to, divide top and bottom by 2, negative 3/5. Possible solution. We're going to go back and do our check. It takes a couple minutes, but it's important. Alright, we're going to look and say, if I subtract 2x from both sides, it's going to give me a positive x value. Okay. If I add 3 to both sides, I'm going to get 12 equals 6x. And I'm going to divide by 6, and I'm going to present my x variable first. And it's going to be 12 divided by 6 is 2 as a possible solution. Okay. We're going to run our check by substituting the two possible solutions into the original given problem. We got a little work to do. We're going to substitute in negative 3/5 first. So you're going to have absolute value of 2 times negative 3/5 plus 9. Absolute value equals 3 minus 8 times negative 3/5. So we're going to get absolute value of negative 6/5 plus 9 equals 3. Negative times a negative in the numerator is going to be positive 24/5. Alright. We're going to consider that this is 3 plus 24/5 here. Alright, so this negative times a negative made this a plus. We're adding the opposite, and we multiplied those. Okay, so make sure that happens. Alright, to add negative 6/5 and a whole number 9, we're going to create like denominators. Purpose of our problem, 5 is a pretty good one. So if that's true, we need to make equivalent fractions. So we're going to have the absolute value of negative 6/5 plus 9 over 1, you can put any whole number over 1. It's going to be equal to 45/5 if we take the top and bottom times 5 to get 5 as a denominator. We're just making an equivalent fraction. We renamed 9 as a fraction with a 5 denominator to match our problem, so we can really just add everything. And we've got 3 plus 24/5 here. If we subtract 24/5 shortly, we're going to be able to do that as well. But let's see what we've got. We've got -6 plus 45. That's the absolute value of that. And in the positive, it's going to be 39/5, all equal to 3 plus 24/5. We're going to subtract 24/5. You can see it here from both sides now. We still like denominators we're working with, and we're going to get 15/5 equals, this goes away, 3. And 15 divided by 5 is 3. Alright, so what that means after running the check is that -3/5 is a solution. Okay, we're going to take our original equation and we're going to pop in 2 for x. I caught the other problem we did. So if we pop in for 2 for x in the original problem that we're given, okay, I'm changing that. So we have the absolute value of 2 times x plus 9. Our other solution to check for is 2 from here. And we're checking with 2 everywhere we see x. Alright, so what we're going to get is the absolute value of 4 plus 9. That is 13. Equals 3 minus 16. 8 times 2 here. So now we get 13 equals a -13. That is false. So, no, this is not a solution. For this problem, x only can equal -3/5 for our final solution. So that's why the check's important. It looks like it could be a solution, but it really is not. All right. We talked about distance and midpoint. So if you have something that you're given in a graph like this on the number line, and you have points on that line, like F is at -8, and then you have something like G is 3, and H is at 7, and you're asked to find the distance and midpoint of G and H. So the distance is going to be here, the absolute value of 7 and 7 minus 3, which equals the absolute value of 4, which equals a positive value of 4. The midpoint is going to be 3 plus 7, all divided by 2. That's 10 divided by 2, which equals 5. Found the distance and midpoint of 2 points on the graph. All right. So in the reverse, if you're asked to write an absolute value equation for the graph, just where two numbers are plotted, such as this, and you say, okay, there's a number plotted at -1 and a number plotted at 5, okay, you still can find the midpoint and the distance. So you're going to have -1 plus 5 divided by 2 for the distance. -1 plus 5 is 4, divided by 2 is 2 for the midpoint. Or for the midpoint, did I say distance? Okay, so the distance now is the absolute value of 5 minus the midpoint, which equals 3, an absolute value which equals 3 for the distance. All right. So what we did was find the distance from an end point to the midpoint. And that's going to give us our equation. Our equation is going to be now the absolute value of x minus 2 from the midpoint information equals 3 from the distance information. And so this equation describes the points that are a distance of 3 units from 2. So anywhere you go, there's a point 3 units from 2 for solving that. All right, I hope this helps, and I'll see you soon.